Hello all. Today I want to solve the last homework that I gave it to you about thermal physics in general. Now the question number one, it says explain how how gas molecules exert a force on solid surface. Since it's only one mark, we said due to the collisions between gas molecules and the solid surface. Now, explain how the increase in pressure of a gas when its volume is decreased at constant pressure. Why there is an increase in pressure when the volume decreased at constant temperature. We wrote this, you can find it in our notes. We said as volume decreases, then the rate of collisions between molecules and the walls, between the molecules and the walls, increases, so greater forces on walls, and this causes the pressure to be increased. Now B, a cylinder of volume 5 times 10 to the power of 3 contains air at pressure of, this is the volume at the beginning and this is the pressure at the beginning. A leak developed so that air gradually escapes from the cylinder until the air in the cylinder is at the atmospheric pressure, which is this pressure. So the pressure decreased. Calculate the volume escaped. Okay. Now there are 4 marks here. Since assuming that the temperature is constant, then we can use pressure 1 times volume 1 equal pressure 2 times volume 2. Now, the pressure at the beginning, it was 8 times 10 to the power of 5. And the volume was 5 times 10 to the power of 3. Centimeter cubed, it's okay, we will keep the answer in centimeter cubed. Now, pressure 2, it's 1 times 10 to the power of 5. What is the second volume of the air? So volume 2 will be, if I do the calculation quickly, it will be 40,000 centimeter cubed. Now this is the new volume of the air, but the air in the cylinder, it was only 5,000. Now how the volume will spread to 40,000? So this means it has been escaped, and this is what the question is. Now how much the volume that has been escaped? The volume that has been escaped, we have the volume must become 40,000, but the container contains only 5,000, so the difference is only 35,000 centimeter cubed. Okay, now this is question number 1. Question number 2. Now this question is about expansion. Figure 6.1 shows a glass flask full of water at 10 degrees Celsius and sealed with a bung. A long glass tube passes through the bung into the water, and the water rises to level X. Here the water reaches this level. When the flask is placed in hot water, so you placed all of this in hot water, and this is normal water, the water level initially falls. This X falls below, a little bit below X, and then rises above X. Suggest why the water level falls. Why the water level falls? Because glass expands a little. So the volume of glass increases more than the volume of the water, because the water has a fixed volume, and now the volume of the water, it's almost stays constant. Remember with me, glass is a bad heat conductor, so the glass will be heated even before the water, because glass is a bad heat conductor. If the flask was made out of metal, then maybe the metal will be heated, and the water will be heated too. So the water will rise up without seeing that it's falling down, okay? Because it will be good heat conductor. So here, the glass, we say glass expands a little, so the volume of glass increases as it gains energy. As it gains energy. Now, the water level rises. Why then? Now, because the water now gains the energy, okay? So now we'll heat energy transfers to water. طبعا surely from glass, although glass is bad heat conductor, but it will become hot, so there will be some conduction between glass and water. So yes, so water now expands. Now maybe you ask me why the rise is greater than the fall. This is simply because glass expands less than water. If you ask me why, because we know that solids expands the least. Solids expand the least. Do you remember? When we talked about solids, we said solids have strong forces of attraction between their molecules. So when they want to expand, we said expansion means they are moving further apart, but there are strong forces, so they can't expand a lot. Liquids, there are little forces, so they will expand a little bit more than the solid. And the gases will expand the most because there are no forces of attraction between the molecules, so they can easily spread away. Okay, now suggest a change to the apparatus that would make the fall and the rise even greater. If you want it to be greater, we said use narrower tube, then it will expand much more and contract much, expand, the glass will expand and the water will expand higher than before. Now question number 3. It says, the water in a copper hot water tank is heated during night. During the day, water cools and thermal energy thermal energy passes from water into the air surrounding the tank. Describe the process by which thermal energy transferred from the hot water to the air. What is the process that transfers the energy from the hot water to the air? Because we know that if you put anything hot there, it will cool down gradually. So what will happen as it's placed, the water is placed in copper hot water. Now, surely there will be some conduction between water and the copper, and then the copper will transfer the heat to the air due to because it's a good heat conductor. So let's write the following. نقول water molecules transfers the heat energy to copper as they collide with the walls of copper. Also, the copper now will transfer heat energy to the surrounding air. Since it's a good heat conductor, also there will be some evaporation and convection, right? So there is convection, there is conduction, there is we did not talk about evaporation yet. We will talk about it after we finish the specific heat capacity, but yes. Okay. Now, state why the rate at which thermal energy passes into the air decreases as water temperature falls. Yani, when the temperature is hot, when water is hot, the rate of transfer to the surrounding is high. When it cools down, that rate of transfer is slower. The answer, since there is little difference in temperature between water and surrounding. So when there is big difference between water and surrounding, the rate of transfer of energy will be high, and when it's cooled down, when there is little difference, then the transfer it will be slower. The manufacturer of hot water tank says that when the outside surface is polished regularly and kept bright and shiny, the hot water will cool even more slowly. Describe with the aid of diagram an experiment to show whether a container with a bright and shiny surface is better to keep at keeping its content warm than one with a dull black surface. So if you have two containers, so I will bring two containers. Let's say here I'll put container 1. Here there is container 2. Here we have thermometer. Here we have thermometer. This is you painted, let's say, shiny container, and this is dull container, dull black container, and both contains water. This is water and this is water. Let's say it's hot water, and these two are thermometers. So what do? We need to use same amount same volume, same mass of hot water in each container at the same temperature. So we can't put one with hot water and one with warm water. No, both should be at 50 degrees Celsius. Both should be at 40 degrees Celsius, whatever. So, and we use the same amount, 1 kilogram, 1 kilogram, half kilogram, half kilogram. Now, you measure the temperature of each water in each container at start to make sure that they are the same, and then after you may specify certain time, so after 1 minute, after 2 minutes. Now you will see which one have bigger drop in temperature within 2 minutes. طبعا we don't wait for 10 minutes because 10 minutes maybe both will reach room temperature. So you don't need to specify time. So you may say, and then after certain time. We know the one with least least temperature fall, temperature difference will be the shiny surface. Why? Because it is bad heat emitter, so it does not emit the heat easily. So yes, this is how do we do it. Now, question number 4, we're talking about Brownian motion. Here we're asking, figure 4.1 shows a small closed transparent chamber containing smoke. If there is a bright light, here the chamber means box, okay? So transparent, so it's a glass box. It contains smoke and there is a microscope to see it. The chamber is brightly lit and observed through microscope. The smoke particles are seen very small bright dots. Describe the movement of the dots. They will move, as we said, they will move randomly in straight lines. Okay, randomly in straight lines. You can mention if you want that they are fast, it could be accepted because air is moving fast. So yeah, could be. Now explain in terms of molecules how this movement is caused. Now this is just the explanation. This is just the explanation of what do you call it? This is the explanation of Brownian motion. We said the fast but unseen air molecules keep colliding with smoke particles from all directions and all the time, which move them randomly, and as we said, randomly in straight lines. Okay, now the last part, describe what is seen as the smoke particles move toward and away from the observer. The brightness will be changed. No, because the bright dots, the brightness increases as they move toward and decreases as they move further away. Okay, that's it. If you have any question, I will be able to answer you in our class. Okay, so just write your questions, and when we meet on Sunday, I will answer your questions there. Thank you for listening. God bless you. Bye bye.